First of all, let me remind you about the half-angle formulas. Sine of u over 2 is equal to plus or minus the square root of 1 minus cosine u over 2, and so forth. And we're going to use that. If we are given this kind of thing, x over 2, we'd like to be able to write it like this. When we do that, we're going to be compelled to square both sides, okay? So, you see where they squared this, and when we do that, well, it's squared already. I was thinking, why didn't they square both sides? Well, this is already squared, if you see that. They didn't have to square both sides because we're already being called to square it. So they replaced cosine x over 2, and then they squared it. Oh yeah, and there's a 2 out in front. So that's what they did down here, and I was thinking, why didn't they square this side? Well, okay. Most of the time we're going to have to square both sides, and when we do that, we're going to introduce the possibility of extraneous solutions, and so we should check our work. But in this situation, we're already being told to square it. So remember that this means the same thing as this. We just like to write it the first way. We like to write it this way to save ourselves parentheses. And then we have a normal kind of quadratic equation here, and we factor out a cosine. And we solve each piece individually, this part and then this part, okay? And we get our answers. And of course, we can always look at the graph, and the graph gives us, where does it hit, where does it hit? Okay, so it hits places, and those are our answers. So we're going to come down here, and we're going to say, and we will verify this with the graphing utility afterwards, but we're going to say, okay, how can I rewrite this? Well, the sine of x over 2. That's down here, and I can write it like that. So let's do that. We'll say plus or minus the square root of 1 minus cosine of x over 2. And we might as well just move that to the other side and square it, huh? Well, we're going to square it. So we square both sides. And again, we are kind of mindful of the fact that when we do this, we could be introducing things that won't really be. I squared it, so the negative goes away. And then, let's see, I'll multiply everything by 2. And I'm going to move this cosine squared x to the other side. Switch sides here. And then I'm going to say cosine squared x plus cosine x minus 1 equals 0. Okay, so I just rearranged some things after I squared both sides. And now I'm just going to factor this like a normal quadratic, kind of like if I were saying 2x squared plus x minus 1. What would that look like? Well, let's see, I'd say 2x. I guess I'd say plus 1. Better put the minus first, right? Because I want the 2 to go with the positive. And then I'll say x plus 1. And that works out just fine. Okay? So I'm thinking about that over here. I say 2 cosine x minus 1 times cosine x plus 1. And that gets me the same thing. I get 2 cosine squared x. I get a plus cosine x in the middle, and I get a minus 1 constant. And hopefully you can see I just substituted cosine x in for x. Now let's see. I have 2 cosine x minus 1 equals 0. So therefore cosine x is going to equal 1/2. What gives me that? Well, let's see. I'll come over here and I'll say half. Well, how about this? We'll say 1 over 2 for cosine of x, which means this over here is the square root of 3, and it must be pi over 3, right? Okay, so x is equal to pi over 3, 60 degrees. And where else is it positive? Well, it's also positive down here in the fourth quadrant. And so we're going to say 5 pi over 3, 60 in the fourth quadrant as well. Okay, so those are my tentative answers. And then I'm going to say the cosine of x is equal to minus 1. Where does that happen? Well, that's over here. That's over here at pi, right? That's the only time I get a negative 1, so x is equal to pi. Okay, so let's try these out because I squared it, so I want to make sure. So let me write this again. We'll say the sine of x over 2 plus cosine x, and I'm going to try my answers out. Alright, so let's see, we'll say the sine of we'll say the sine of pi over 3 over 2, which means the sine of pi over 6, right? Plus the cosine of pi over 3. We're equal to, did I write that down? It's supposed to be equal to 0. Okay, so if we use our reference triangles, the cosine, or the sine of pi over 6 is 1/2. And the cosine of pi over 3, that's the cosine of 60, is 1/2. And so we'd get 1. And we'd say, I'm not liking that answer. I would say, no, that's not true. So we throw that answer out. And then we try it again. We try the sine of 5 pi over 3 over 2. So this is going to be the sine of 5 pi over 6 plus the cosine of 5 pi over 3. I guess I should write that up there. Okay, so that's what I'm plugging in new values here. And let's see, the sine of that is going to give me a plus answer, right? Plus, it's still 30, but it's in the second quadrant, but that's positive for sine. And the cosine in the fourth quadrant is also positive. And these are supposed to be equal to 0, and they're not. Okay, so we have another one fail. So no thank you, no thank you. Let's try pi. I hope pi works. So let's see, what's my original one? Here's my original one right down here. I'm going to say the sine of pi over 2 plus cosine of pi is supposed to be equal to 0. Okay, well, let's see, what's the sine of pi over 2? That's 1, right? And the cosine of pi, that's negative 1. And that really is 0. So I'm going to say that x is actually pi and nothing else. That's the answer that I'm going with. And my graph will bear that out. In fact, it's the only one that survives by graphing. And out of my 3 possibilities algebraically, 2 of them bite the dust. But we did find the right answer. If it seems a little futile, I'm sorry. That's how it goes. When we square things, we introduce little extras.